Well, welcome everyone. Today we're going to talk about how to solve two-step equations. The process will feel fairly familiar as you have already mastered one-step equations. So we'll still be working within that same process, mainly the idea of inverse operations to isolate the variable. The expectation is that as I go through the examples, you fill in the information along the way. A good rule of thumb is when I write, you write. Let's start by reviewing some vocabulary. Our first term is equation. An equation shows two sets of values that are equal to each other, using an equal sign. With that understanding, let's identify which of the examples below represents an equation. Letters A, D, and F represent equations. Just as a reminder, if there is no equal sign, those are called expressions. So letters B, C, and E represent algebraic expressions. Our next term is variable. A variable is a letter that takes the place of an unknown number. Let's circle or highlight the variable in the equation. In the equation 3x plus 8 equals 14, our variable is x. Our next term is coefficient. As a reminder, a coefficient is the number being multiplied by a variable. Let's circle or highlight the coefficient in the equation 3x plus 8 equals 14. Our coefficient is 3 because 3 is being multiplied by x. A constant, on the other hand, is a number with a constant value. A number with a constant value, it stands alone without being multiplied or divided by a variable. Let's circle or highlight the constants in the equation. In the equation 3x plus 8 equals 14, we actually have two constants, 8 and 14. The next phrase is one that might be familiar, inverse operation. The inverse operation of a given operation can be thought of as reversing the operation. Take a moment and see if you can identify the inverse operations of adding, subtracting, multiplying, and dividing. Pause the video and record your best answers. All right, did you get them right? The inverse operation of adding is subtracting. The opposite of subtracting is adding. The inverse operation of multiplying is dividing. And of course, the opposite of dividing is multiplying. Now, this idea is most often used to solve equations for a specific operation. Now that we have a good sense of our setup for our equations, what to look for with the equal signs and our coefficients and our constants, and of course our inverse operations, let's dive in to a few examples. Example number 1 reads x plus 13 equals 42. We'll show our steps using inverse operations. Recall that the goal of solving equations is really twofold. It's to use inverse operations to isolate the variable. We have to get x alone. Since the inverse of adding 13 is subtracting 13, we'll take 13 away from both sides. On the left side, that isolates the variable. X plus 13 minus 13 is x. And on the right side of our equation, the difference of 42 and 13 is 29, so x equals 29. But let's go ahead and do a quick check to make sure that we've done it correctly. To check any equation, replace your variable with your given solution. If we believe that x is 29, our equation x plus 13 equals 42 becomes 29 plus 13 equals 42. Even if it seems like the simplest calculation, grab your calculator just to double check that 29 plus 13 does indeed equal 42. You should end up with the same value on both sides. 29 plus 13 is equal to 42, and on the right side we also have 42, so we have evidence that our solution is correct. Example number 2 reads x minus 8 equals 23. The opposite of taking 8 away is adding 8. Now recall that you'll have to do that on both sides. That isolates a variable on the left side and gets us to a solution on the right side. 23 plus 8 is 31. Let's do a quick check. We'll substitute in 31 to our original equation, x minus 8 equals 23, to read 31 minus 8 equals 23. Grab those calculators and verify that 31 minus 8 is indeed 23. And if you get the same thing on both sides, you know you've done your equation correctly, and you can confidently record your solution, in this case, x equals 31. Example 3 is a little bit different. There's no addition or subtraction. In fact, there's some multiplication. 2x equals 122 is the same as 2 times x equals 122. The opposite of multiplication is division. To show division, we'll use a fraction bar. It's a helpful reminder to restate that we always divide when we see multiplication, and specifically, we always divide by the coefficient. Whatever's in front of the variable, in this case 2, is what we'll use to isolate the variable. 2x divided by 2 is 1x, which is the same as just x. And now we've isolated our variable. 122 divided by 2 is 61. Let's go ahead and check our solution. To check our solution, we'll replace x with our believed solution of 61. 2x equals 122 becomes 2 times 61. And we'll check and see if that does indeed equal 122. Again, use your calculator, you can never be too sure. 2 times 61 is indeed 122, so we can confidently say that our solution is x equals 61. And for our last one, we see division, x over 2 equals 14. The opposite of division is multiplication. It might help to rewrite this problem so you have a little more workspace. Since the opposite of division is multiplication, we'll use that to isolate our variable. Similar to number 3, where we divided by our coefficient, we'll also, in this case, multiply by the number that's paired with the variable. The opposite of dividing by 2 is multiplying by 2. Whatever you do on one side, you have to do to the other. On the left side, we'll multiply 2 by x over 2. Recall that that's the same as 2 over 1. Now, before we simplify, I'll show you how this ends up isolating the variable. Let's go ahead and just take this step by step. 2 times x and 1 times 2 creates a product of 2x over 2. But that simplifies to just x. That's how we're isolating the variable on the left-hand side. And on the right-hand side, the product of 14 and 2 is 28. We don't have a whole lot of room for our check, so we'll go ahead and just do that mentally. The original equation is x over 2 equals 14. If we change x to 28, 28 divided by 2 is 14, so we can confidently say that our solution is 28. At this point, please pause the video and make sure that you have everything recorded from our first page. All right, we're finally ready to move into two-step equations with rational numbers. On the left side, we'll go ahead and work through the steps before we get into any examples. Step 1 says, use the blank operation to remove the blank and apply to both sides of the equation. We will use the inverse operation to remove the constant and apply that to both sides of the equation. Then we'll move on to step 2. For step 2, we'll use that inverse operation to remove the coefficient and apply to both sides of the equation. And lastly, you'll write your final answer as an equation, either x equals a or a equals x, meaning it doesn't matter what side your x ends up on, and I'll walk you through a few examples of that. Example E reads 2x plus 10 equals 15. It might be helpful if you make what's called a t-chart. A t-chart is a vertical line underneath the equation and vertically through the equal sign. What it does is set a reminder that you should be applying your inverse operations to both sides of the equation. A helpful way to remember what to do first when you are solving two-step or more multi-step equations is to identify that you are identifying a missing part of an equation, as opposed to evaluating an expression. But you'll likely recall that when we calculate expressions, we use PEMDAS. But again, we are not evaluating expressions, we're solving equations, which means we're working backwards to undo the equation and find the missing part. So we're not going to apply PEMDAS. We're actually going to work in reverse and apply SAD-MEP. That's simply PEMDAS backwards, meaning we'll tackle any addition or subtraction first, undo some division and multiplication, and then eventually we'll get to undoing some exponents and we'll talk more about parentheses. But for now, let's undo, in letter E, the addition of 10 by applying the inverse operation of subtracting 10. When we take 10 away from both sides, we'll want to view it as a left and a right side to keep our equation balanced. 2x plus 10 minus 10 is 2x. Bring down your equal sign and find the difference of 15 and 10, which is 5. Now we'll want to undo any multiplication or division. 2x means 2 times x. The opposite of multiplying is dividing. We'll divide by our coefficient to isolate our variable and get our solution. 5 divided by 2 is 2.5. Let's pause and do a quick check to make sure our answer is correct. When you're doing a check within a two-step or more equation, all you have to do is what you did with the one-step equations. Replace x with your solution and check and see if your equation is balanced. Since we don't have a lot of workspace, I zoomed in just on the top right there to do a quick check. Recall that x was a part of a coefficient 2x plus 10 equals 15. We now believe that x is 2.5. So all I did was replace my x with 2.5 into my equation, and I'll check and make sure that 2 times 2.5 plus 10 does indeed equal 15. Again, use your calculator to be sure, but it does indeed equal 15, which means we have a balanced equation, and we can confidently say that our answer is 2.5. Let's move on to example F. Now in example F, I see subtraction, so I know according to SADMAP, I'll need to undo that first. Let's map out our t-chart so we recall to do those inverse operations on both sides. That gets us a little bit closer to isolating the variable on the left side, and on the right side, we'll go ahead and find the sum of 28.8 and 1.2. After that, we'll undo the multiplication that's being presented in the term 5x. The opposite of multiplication is division. Recall that you'll divide by the coefficient. That isolates the variable on the left and gets us a quotient of 6 on the right. Let's do a quick check. When we substitute 6 in for x to the original equation, we do get 28.8, verifying that our solution is indeed 6. Let's move on to examples G and H. If you'd like to start trying these on your own, you can simply pause the video and watch up until the end when I give that grand solution. Our first step will be to subtract 3.1 from both sides. This gets us a little bit closer to isolating our variable, but we're not quite there yet. On the right side, the difference of 5.2 and 3.1 is 2.1. Now we'll have to undo the division that's being represented with the fraction bar. Remember, all fractions are division problems. The opposite of division is multiplication. So to solve our problem, we'll multiply both sides by 10. Multiplying by 10 on the left side isolates our variable, and on the right side gets us to our solution. The product of 2.1 and 10 is 21. Our solution is 21. At this point, I won't show you how to do a check anymore, but I will encourage you to do them since we've done them with each type of problem so far. The next example reads 3/4 x minus 6. Let's undo that subtraction by adding 6 to both sides. After we've added 6 to both sides, we'll have to undo the multiplication that's being shown between 3/4 and x. I know it might look like a division problem because all fractions are division, but 3/4 is actually being multiplied by x. Recall that if you have a coefficient and a variable right next to each other, there is that invisible operation between the two of multiplication. Now technically, to solve for x, we'll do the inverse operation of multiplication, which is division. But because our coefficient is a fraction, our coefficient is 3/4, when we divide by 3/4, as we do with any fraction, we actually end up multiplying by the reciprocal. I'll say that again. When we divide by fractions, recall, keep, change, flip, where we actually end up multiplying by the reciprocal. So instead of showing that division of 3/4, we're going to jump right into multiplying by the reciprocal of 3/4. On the left side, we see lots of cross-canceling, which is really where that x becomes isolated. And on the right side, we'll find the product of 9 and 3/4. Sorry, just to clarify, the product of 9 and 4/3. 9 times 4/3 is 36/3, but that simplifies to 12. At this point, please pause the video and make sure that you're caught up and you've recorded all of the examples along the way. For now, we're going to skip the practice problems and move on to a couple of more examples on the next section. If so, take a moment to fill it in. A little more challenging are equations that have parentheses, but this should be familiar to you. When you see parentheses and there's an expression inside, like 3 times the sum of x, the difference of x and 2, you probably recall that we'll need to distribute before we apply our inverse operations. But there's actually another way that we can do it as well. Let's go ahead and start with what's probably most familiar, option 1. We're going to use the distributive property to simplify the parentheses, and then we'll continue to solve using inverse operations. As a reminder, that means we multiply the number on the outside by the terms on the inside. 3 groups of x minus 2 is 3x minus 6. We'll bring down our equal sign and our 15. And then from there, we would just continue solving using inverse operations. Alternatively, we can do option 2 as well. Option 2 says that we can use inverse operations. We'll use those inverse operations to eliminate the coefficient of the group. In this case, we will divide both sides of the equation by 3. To show that division, just like we've done with our other equations, we'll show that inverse of dividing by 3 on both sides. And what that does is simplify our equation a little bit so that we can get it down to that one-step equation of x minus 2 equals 5. And from there, we'll just use our inverse operation of subtraction. We'll add 2 to both sides. And look at that, we end up at x equals 7, which is exactly what we had in option number 1. So either option is fine, whichever one you prefer. All right, at this point, we're going to move forward and complete all of the odd numbered problems together in this video. When the video ends, you'll be expected to complete the even numbered problems on your own. So here we go. Let's take a look at number 19. Number 19 reads, negative 2 times s plus 10 equals negative 12. I prefer option 1 from our example above, where we distribute first and then move into those inverse operations. So that's what I'm going to do. If you want to try option 2, I can show you that as well in the next problem. All right, if we have negative 2 times s plus 10, that simplifies to negative 2s minus 20. Bring down that equals negative 12. And from there, we can go ahead and start working through our t-chart with our inverse operations. The first thing we'll want to do, according to SADMAP, is undo any subtraction or addition. So we'll go ahead and start by undoing that minus 20. Now remember, whatever you do on one side, you have to do on the other. So it's not as simple as just adding negative 12 and 20. You also have to add 20 to the left side, which gets us a little bit closer to isolating that variable. Bring down that negative 2s on the left, and on the right, we'll go ahead and do negative 12 plus 20. Now we have an updated equation, negative 2s equals 8, and we'll go ahead and undo that multiplication, dividing by our coefficient. On the left side, we've isolated our variable, and on the right side, the quotient of 8 and negative 2 is negative 4. For number 21, I'll show option 2 from above so that we're able to apply either method to simplify our equations. Number 21 reads 5 times the sum of negative 2u and 7 equals 25. Rather than diving into our distributive property, we have the other option of undoing our multiplication by dividing by 5. Again, whatever you do on one side, you do on the other. And that gets us a little bit closer to isolating the variable. From there, we're able to apply our inverse operations using a t-chart just like we did with our two-step equations. The opposite of adding 7 is subtracting 7. And of course, whatever we do on one side, we have to do on the other. On the left side, we've simplified to negative 2u, and on the right side, the difference of 5 and negative 7 is negative 2. Our last step will be to undo the multiplication of negative 2 times u by dividing both sides by our coefficient. Since our coefficient is negative 2, we'll divide both sides by negative 2. That isolates our variable on the left, leaving just u, and on the right, negative 2 divided by negative 2 is positive 1. Now at this point, I'll pause and identify the process for checking our solutions with these types of equations so that you have that as a strategy when you're doing your homework or when you're taking a test or quiz. As a reminder, when we do a check, we simply replace the variable with the solution that we think we found. So in the original equation, positive 5 times negative 2u plus 7 equals 25, we're going to replace our u with our proposed solution of 1. So I'm just going to rewrite this equation, 5 times negative 2 times u, which we believe is 1, plus 7, and bring everything else down, our equal sign and our 25. Now, because we're doing a check, we actually do have to do PEMDAS, right? We're evaluating an expression, not solving an equation at this point. We're just checking our solution. So we'll do what's in the parentheses first. -2 times 1 is -2, and -2 plus 7 is 5. So now we've simplified our expression to 5 times 5. And definitely at this point here, you do want to pause and ask yourself, is that a true statement? Don't assume that it is. I mean, this one's pretty straightforward, but grab your calculator and be sure that you get the same thing on the left side, 25, as you have on the right side, and that's your evidence that you've solved your equation correctly. U is indeed 1. All right, before I move into number 23, just a reminder that you should be pausing this video whenever you need to, just to make sure that you get everything copied down and you leave with a full and complete set of notes at the end of the lesson. All right, let's take a look at number 23. It reads 0.5 times -4w minus 10 equals 14. I'm going to go back to that first option where we distribute first and then move into our inverse operations. All right, as we distribute, be sure to watch your signs. You're multiplying a positive 0.5 over a -4w minus 10, which makes our simplified expression -2w minus 5. Just be careful with those signs. All right, we'll dive into those inverse operations now. The opposite of subtracting 5 is adding 5. And that gets us a little bit closer to isolating that variable, but we're not quite there, right? A -2w equals 19, because 14 plus 5 is 19. And then we'll divide by our coefficient of -2. We're dividing because it's the opposite of multiplication. That gets us a little bit closer here. We're so close, w on the left side, and then we'll do 19 divided by -2. I would encourage you to check your solution. I just did using my calculator, so I know for sure that w is equal to -9.5. All right, and the last one we'll do together is number 25. It's an error analysis. Each example below has a process error. Identify the error, then solve for the correct value. Let's zoom in here on number 25. It reads -0.4y plus 19 equals 17. And it looks like in step 1, they subtracted 19 from both sides, leaving -0.4y equals -2. And then in step 2, they added 0.4 to both sides, isolating the variable and getting us to a solution of -1.6. I'm going to ask you to just kind of follow those steps again from top to bottom and see if you can identify that error. All right, did you find it? The error is in step 2. The correct step is to divide, not to add, because it's the inverse of -0.4y or -0.4 times y. So let's go ahead and finish off the problem correctly from step 2. -0.4y equals -2, again means -0.4 times y. So we'll do the inverse operation, which is dividing by -0.4 on both sides. That isolates our variable on the left, getting y alone. And then our quotient on the right side of -2 and -0.4 of +5. A negative divided by a negative is a positive. So we'll bring that over here into our correct answer of y equals 5. So now's a good time to pause the video if you need to and compare your notes with what I have on the screen here. If you miss anything along the way, that's okay. Just pause the video and fill in the information along the way. And lastly, please be sure to rewatch and rewind to verify that you've completed the handout entirely. Your job is to complete the even numbered problems that we did not do together. If you don't finish in class, it's homework. Please submit this to Schoology when you're finished.